So how do we do this when it becomes more challenging? Well, we should identify any horizontal and vertical shifts. Again, that's with adding and subtracting things. Identify horizontal and vertical stretches, expansions, or reflections. So for example, if I have 2 times arc cotangent of x, then what's going to happen is the vertical asymptotes are going to be stretched further away. So instead of being at 0 and pi, it'll be at 0 and 2 pi. Transform the original inverse trig function using the shifts, stretches, and reflections that you've identified, and then take the reciprocal for cosecant and secant. So let's say we have this. Well, let's start by graphing what would it look like with cosine. So it'd be shifted left 2. So if it were arc cosine, we would shift it left 2, and then it would be going from -1 over to -3, and it would still, because it hasn't been changed vertically, it would still be going like this, and that would be what the arc cosine of x plus 2 looks like. So that's not our answer. When we're looking for arc secant, we can take our asymptote, take our equilibrium and turn it into an asymptote, and then use our boundary points as starting points and erase our original cosine graph, or arc cosine graph. So that is arc secant of x plus 2. Now we have arc cosecant of x minus 3 plus 1. Well, the original arc sine would look like this. It's been shifted right 3 and up 1. Up 1 is not going to bring this point onto the axis. Remember, this is down at -pi/2. So if we take -pi/2, that's about -1.57. So if we add 1 to that, that'll become about -0.57. So we're not going to be at a nice place in terms of y coordinates. Anyway, we're shifting it right 3, 2, 3. Let's label our y-axis. I could label it in ones or in pies. I'm going to label it in ones. So -3, -2, -1, 1, 2, 3. So our y coordinate's going to be going from, well, this has been moved right 3. So it started from -1, now it's going to be at 2 for the y coordinate, for the x coordinate. And it's being moved up 1 to be at -0.57. So this coordinate is +2 because it's been shifted right 3, and -pi/2 plus 1 because it's been shifted up 1. Now we can shift the other points. So the 0, 0 would easily be at 3, 1. And then this point would have started at 1, pi/2. So now that's going to be moved by moving it right 3. It'll be at 4. And then pi/2 plus 1 will be pi/2 plus 1, which is going to be about 2 point something. So 4, here's 4 as an x coordinate. 4, somewhere between 2 and 3 is going to be pi/2 plus 1. So here is our arc sine graph, and that's not our answer. We want to be using our equilibrium point as an asymptote, then take our boundary points and throw them toward the asymptote. That's not a technical term. So I'm going to erase my original arc sine, and now what we are left with is arc cosecant. Again, the process that I did was I identified that it was shifting right and up. There were no stretches, expansions, or reflections. I transformed it with arc sine first. If you're forgetting how to transform arc sine, go to yesterday's videos. And then take the reciprocal, and that's how I got the asymptote and it going outward. Thanks.